Hey everyone, this is Ashwin here. In this video, we're going to see how to fine-tune an LLM using your dataset. So in the previous video, we have seen how to use Unsloth and use Llama 3 for inference. So you just use the same code structure. We will just resume for the fine-tuning process. So install all the dependencies that you want to install. So install dependencies, and then for inference just load the model and set it for inference. Use the alpaca prompt and use the instruction that you want to get the response from the model. So this is how you can get response from the model. For fine tuning, you just use parameter efficient fine tuning. For that, you have to change the model with some parameters. So model equals fast language model dot get PEFT model, and pass the model as a parameter which we already loaded, and then rank. I will just set it as 16 rank, and alpha is 16 is like a default parameters which you can use, but for experimentation you can change it if you want. LoRa alpha, that also I will set it as 16. Then target modules. So target modules specify the layers which you want to train. If you specify more target modules, means it will train as much layers as possible. If you just want to train a few specific areas in the LLM, means you can also do that. So for now, I'll just specify all the modules available, and later based on your research you can change it however you want. Usually to get best results, it's always better to use all the modules, and it also depends on the dataset size which you are using. Gate projection, approach, down projection. Okay, these are the target modules. LoRa dropout, I will set it as 0, and bias, for this I will set it as none. Then use gradient checkpointing. Sometimes it's not even suggesting anything, so this will reduce the memory, and it will also improve the memory efficiency. So this is true. And random state 42, and max sequence length. So I will use the same as before, which is 2k tokens. Okay, so this is how you can make the model trainable in our small GPU. You can see our GPU have like 16 or 15 gigs of memory. So we have to consider that. As this is a 8 billion model, you cannot load the entire model, and okay, this is a string. As I'm saying, you cannot load the entire model into these 16 gigs of RAM. You have to use parameter efficient fine tuning to fine tune just the necessary parameters, and leave the rest of the rates as it is, which is the first few layers. Once this is initialized, then we have to use this alpaca prompt. For reference, I'll just paste it here. So this is the dataset we are going to use, and this is the common prompt for Llama. If you are using Mistral or any other model, just make sure to do the research and use the necessary prompt accordingly. For our case, I will use this, and after this we have to define the response. As we are going to use alpaca cleaned dataset, we have to format it like in this use case. So def format input prompt examples, which is the data set. From examples, get the instructions examples of instruction, inputs, examples of input, and outputs, examples of output. So I am just using this because I am going to use the data set which is already defined in the model. If you have a custom data set, means you can just format it in this manner. This is just like a list of instructions or a data frame. So text equals a list for instruction comma input and output in zip of instructions inputs outputs. Text equals alpaca prompt dot format of instruction input output, then text dot append text. It'll just a list of this text, and then written as a dictionary text, the list of text. So this is how the model accepts the formatted text. So this is the function. After this, import the dataset. So from datasets, import load dataset, and then dataset equals load dataset. As I already mentioned, I am going to use alpaca cleaned dataset. Again, this dataset is available in Hugging Face. You can directly go there and get this link. If you just copy paste this text, it will lead you to the link, and then split equals train. I'm just going to get the train data alone, and dataset equals dataset dot map format input prompt and batched equals true. So that's it. Let's run this. Okay, this is cleaned. Run this. Okay, it's downloading the dataset. I'll just format the input prompt. I'll just add some comments here and there. The list with keys. So you can also check what is inside the dataset. Okay, I just mapped it into a text. So if you check inside the dataset, so it has the features, instruction, input, and output. So this is the existing one, and after that we just added this text variable as well, and we have a total of 51,760. Let's try to get a single text. So here you can see this is the first sample, this is the output, input, instructions, and this is the complete text. So this is the alpaca prompt which we used. As you can see, it has the instruction keyword, and then input, and then the response, which is this. Okay, so this is about the input. Let's train the model. Okay, overall this is the model training part. I'll just go with it. From TRL, import SFT trainer, and then from transformers import training arguments. Then we will initialize our trainer, SFT trainer. Okay, this is SFT trainer, it automatically updated. So usually we don't use the trainer, we will just directly use the transformer trainer module. But for training LLM, you have to use this supervised fine-tuning trainer. And here model equals model. Just pass the model which you loaded previously here, which is a PEFT model. I will add it here, PEFT model. Then train dataset. If you have evaluation dataset, you can also add that, like dataset of train, dataset of test, something like that. You can also see the parameters here, train dataset, eval dataset. You can just say train dataset of train, eval, like that. You can just customize the training. Dataset text field. So this is the formatted text field which we mentioned before. So which is the text, and then max sequence length, which we already defined multiple times, which is 2k tokens. And then the training arguments equals training arguments of, again we have to go inside it, per device train batch size. So this is the batch size for the GPU. As this is a LLM, we have to specify very low batch size, as the LLM takes a majority of the space in the GPU. And gradient accumulation steps, which is 4. Again, you can change this parameters if you need. Warm up steps, here I'll just specify it as 10. And max steps, we have a very big data set. For now, I will just specify the max steps as 30. So it will just train until 30 samples. If you want, you can just specify 500 or 1000 and set the number of epochs. For now, I'm just training it for one epoch, which is 30 steps itself, as this is like a demo tutorial. Learning rate 2e power 4. You can also use 2e power 5. Again, this is depends on the model and the dataset size. FP16. We have floating point and B float as well. So you have to initialize it according to the GPU. To automate that, you can check it whether it is supported or not. CUDA is BF supported. So based on that, it will update. And BF16 equals, you can just use this directly. If you know what floating point you can use, you can directly use this, but I would specify this if you are using it in different machines. Optim equals Adam W 8-bit. Weight decay. All these are like neural network parameters only, but here we are using it for LLM. Only few changes is like we are using a PEFT model, and all of the things are in quantized state. Not even quantized, it's like a floating point 16 we are using. Usually we will use flu 32 if it's like a smaller models. LR scheduler type. Again we have linear, cosine, exponential, etc. You can also customize it if you want. Then seed equals 1 2 3 4. This just initializes the model with specific weights. Usually when you rerun the model, it will give different results. Using this random state and seed, you can try to reproduce the same results again. Output directory, I will specify it as outputs. So this is the whole configuration for training, and run this. So it's just mapping everything, and after that trainer stats equals trainer dot train. You can also do trainer dot train, but it won't store the stats if you want to visualize it in the form of graph. That's why I'm using this. Let this complete. Okay, this is completed. After that, let's start the training. So here you can see you can use Unsloth for faster fine tuning, and it also mentioned how many GPUs you have, how many samples, batch size, num epochs, which is only one. You can set the number of steps based on your data set, and specify around like 3 to 4 epochs, and again this is also depends on your dataset size. Here you can see the training loss. If you are using eval dataset, you can also see the evaluation loss, but again you have to specify this per device, eval batch size, everything you have to specify. So once the model is trained, if you want to save the model, you can use the inbuilt parameters like model dot save pre-trained. Just specify the directory. I'll just say output model, or I will just specify best model. Again, this is not a best model. We are just training it for like only 20 steps. And we will also save the tokenizer. Save pre-trained. We will set it in the same directory, so it will be easier for us to reload. Again, you can also use this, or Unsloth also have like Unsloth save model, where you can just pass the model and everything. I will also add that as like a commented section here. Unsloth, or I will have it in a new cell, it will be easier. Unsloth save model. So you have to import from Unsloth. Import Unsloth save model, and Unsloth save model, pass the model, tokenizer, the directory name, I will say Unsloth model. I think that's all you have to do. Okay, we are training it for 30 steps. Let this completes. You can see the loss is like slightly oscillating because we are using very less samples. Like 30 steps is not much. Okay, now the training has been done. We can also see the trainer stats. You can see the steps, training loss, metrics, everything. You can just see it here. And if you want to get specific variables, you can just use this. Then let's save the model using both the types. Okay, let's open this. This is the best model using the inbuilt arguments. You can see the adapter weights here. If you want to merge the model, you can also use that, like merge pre-trained. There is a function. You can also check the documentation. So this is the tokenizer related files, and this is the Unsloth model. It also have the same thing. You can use anything you want. After this, if you want to use the trained model for inference, as I mentioned before, how to use this inference text, make the model suitable for inference, and then have the instruction input, everything like this. Paste it here, and everything else remains the same. You can just run this. So here it replied as OpenAI. So it's just more straightforward compared to before. So this is how you can fine tune the LLM and save it and reuse it with the inference. So this is a straightforward way of doing it. Even if you are changing the model means, so you just have to change the prompt, which is the dataset formatting, which will be different for all the models, but the rest of the steps are same. And again, based on your experiments, just change the parameters and play around with it, and use the evaluation dataset to see whether the evaluation loss is improving or not. That's pretty much it, guys. This is how you can use the LLM end to end. If you have any queries regarding this video, please leave a comment below. Other than that, if you like this video, hit the like button, and thanks for watching this video.